Functions of logarithmic functions. Parent functions always generate other functions in the same family. For instance, the parent function f of x is a log base 10 of x. And if we change just the sign in the front of the parent function, in the front here, if we change just the sign, we write a minus, then the new function that we create, g of x is equal to minus log base 10 of x, and is going to be the reflection of the parent function over x-axis. And now, if we have a parent function here, f of x is a log, the same, log base 10 of x, and if we change the argument, the sign of the argument, a minus here, we create a new function which is a g of x. And in this case, whenever we change the sign in the argument here, in the x, we change the sign, then we're going to have the new function is going to be a reflection of the parent function over y-axis. And this kind of the reflection is reflection over y-axis. So the parent function here, the new function, is a reflection of a parent function over y-axis. So now horizontal translation, and we already talked on before, but just let me mention here a little bit. So I'm going to talk about all transformations that occurring in the logarithmic functions. In this case, the parent function is the green function, is a log base 10 of x, and the new function here, if for example in the argument here log base 10 of x minus 2, it means that the parent function is going to move 2 units, the intercept point is going to move 2 units to the right. So 1, 2 units. So the new function h of x is a log 10 x minus 2. But in a case we have the other function g of x, which is a log base 10 of x plus 2. If it's a plus 2 here, and what does it mean? It means that the parent function is going to move 2 units to the left. So in fact, the x-intercept of the parent function, this point here, is going to move 2 units to the left. And now the intersection point here was, for example, 0, 1. And for the new function, g of x, that is a log base 10 of x plus 2, the x-intercept is minus 1 and 0. And of course, the asymptotes are going to move, and all of them, log function, they have a vertical asymptote. In this case, for example, vertical asymptote, because moves 2 units, is going to be x is equal to the vertical asymptote. And in this case here, the vertical asymptote is going to be x is equal with minus 2. So the vertical asymptote moves 2 units, and whole graph moves for 2 units to the left. So now let's go to the next function when we have a vertical translation of logarithmic functions. It's happening here, for example, f of x is a log base 10 of x. This is a parent function. If we have a log 10 base 10 of x plus 2, whenever we are increasing for some value, this value here, the value c, then it's increasing up or down, depend of the sign in the front. In this case, we have plus 2. So the x-intercept is going to move 2 units up, this x point of the intercept. And here is going to be 1 and 2. And now the new function, what we have, h of x is equal with the log base 10 of x minus 2. The x-intercept is going to move, because it's minus 2, is going to move 2 units down the x-intercept. And the x-intercept here is going to be 1 and minus 2. And now let's move to the next function. So now we have a vertical stretch of logarithmic functions. Vertical stretch happen, for example, when the coefficient here is greater than 1. For example, we have a parent function f of x is equal to log base 10 of x, and here inside the parentheses, if the coefficient in the front of the x increases is greater than 1, we have a vertical stretch. Vertically up it goes to the stretch, And the greater is the coefficient, the greater is going to be the stretch of the parent function in order to reach the new function here. And this is a vertical stretch of the logarithmic functions. And now vertical compression of logarithmic function. Now the parent function f of x is equal to log base 3 of x, and this family was going to happen here, and from the coefficient is smaller than 1. If it's smaller than 1, then we have a compression of the parent function in order to reach the new function here. For example, the g of x is equal to log base 3 of 1.5 of x. So we're going to have a vertical compression down. So now, for example, h of x, the green function, log of base 3 of 1/5 of x. So this is smaller than 1 over 2. The smaller is the value. The more it approaches this value to the 0, the more the compression is greater. So h of x has a greater compression from the parent function to here than g of x, then this compression from red function to the blue function.